we want to express the repeating decimal 0.55555 forever, sometimes written as 0.555, that you put a line above the last one to indicate that it repeats forever. We want to express this repeating decimal as a ratio of two integers or as a rational number. Now, repeating decimal is always a geometric series. So this one is 0.5 plus 0.05 plus 0.005 plus 0.0005 and so on. A geometric series always has a common ratio between terms. We call that R. If you take any term except the first and divide it by the previous term, the ratio will be the same. Let's check R here. It's 0.0005. We'll take that term divided by the term before it, 0.005. We see that that's equal to 0.1 or 1/10. And this will be true for any two adjacent terms. So a term divided by a term prior to that, the ratio will always be 1/10, in this case 0.1. We can take then this series and express it in the following way. We can express it either just like we did above, 0.05 plus 0.005 plus 0.0005, or we can express it as 0.5 plus 0.5 times the ratio, which is 1/10, plus 0.5 times the ratio squared, and then plus 0.5 times our ratio cubed, and so on. Now, expressed in this way, we can write it using the summation notation. Using the summation notation, this is n equals 0 to infinity, 0.5 times 1/10 to the n. And recall that in standard form, a geometric series is written as n equals 0 to infinity, a times r to the n. And when r is between -1 and 1, this series is going to converge. So converges to a divided by 1 minus r. Well, in our case, if we use the summation notation, let's bring it back over here. It's n equals 0 to infinity, 0.5 times 1/10 to the n. This is in standard form. R is 1/10. It's clearly between -1 and 1. So this converges to 0.5 divided by 1 minus 1/10. And this is 5 over 10 over 9 over 10, which is 5 divided by 9. So we just found that the rational number 5 divided by 9 is equivalent to a repeating decimal 0.5555 forever. And you can check this using your calculator by just plugging in 5 divided by 9, and you'll see that the answer is 0.555, repeating as much as your calculator will allow. Now, we can also derive this answer without the summation notation. If I write the series again here, 0.5 plus 0.05 plus 0.005 and so on, you have to make sure that you're working with a geometric series. So this is r, which is 0.1. This is also same r, which is 0.1. And this is r, which is 0.1. That ratio also. If the series is not geometric, this technique, somewhere the r's will be different and you cannot apply this formula. But once we establish that this is a geometric series, which a repeating decimal is, then as long as r is between -1 and 1, this will equal to the first term in the numerator. So first term. And in the denominator, 1 minus the common ratio. And in this case, the first term is 0.5 and the common ratio is 0.1. So we get the same thing, of course, which is 0.5 divided by 0.9. And that, of course, is 5 divided by 9. So you can use either summation notation or you can use this formula without using the summation notation. Now, if we now look at other types of repeating decimals with one digit repeating. So for example, if 1 repeats, we can use the same technique to show that that is equivalent to 1/9, and then if 2 repeats, that of course is 2/9, and so on. For more videos, visit www.mathprepvideos.com.